the energy and power signals. If a signal g of t measured in volt is applied to a load resistor R, then the instantaneous power is in watts is P is given by g of t square R. Here the g of t square is basically V square, voltage square divided by the resistance. This one can be, if you remember the power equation, P is equal to V over I, and we can say V is equal to IR, and therefore we replace I with V over R. It's not V over I, VI is equal to VI. That's the power equation, and this is Ohm's law. Is equal to V is equal to IR. So if you rearrange, I is equal to V over R, and if you replace this one, you will get this GT square R. That is this voltage actually, G of T. Normally we use normalization. R is equal to 1 ohm. In many applications, the effect of the signal varies as the log of the signal. Example, human hearing and vision. Power can be expressed in decibels, which are logarithmic and relative to some standard power. If P is measured in watts, then power in dB watts is 10 log 10 T, power relative to 1 watts. Power in dBm or dBmW is log 10,000 P, 30 plus 10 log 10 P. 1 bell is too large to be useful. Total energy of a signal. The signal energy Eg of g of t is defined for a real signal as Eg is equal to integration negative infinity to infinity g square of t dt. In the case of complex valued signal g of t, the energy is given by Eg is equal to integration negative infinity to infinity absolute value of g of t square dt. A necessary condition for energy to be finite is that the signal amplitude approaches zero as t, absolute value of t approaches infinity. Otherwise, the above integral will not cover h. If the condition doesn't hold, the signal energy is infinite. The signal g of t is an energy signal if Eg is less than infinity. The power signal must have an infinite duration. In case of signal with infinite energy, example, periodic signals, a more meaningful measure is the signal power. Pg is equal to limit t approaches infinity 1 over t integration negative t by 2 to t by 2 g square of t dt. For a complex signal g of t, the signal power is given by Pg is equal to limit t approaches infinity 1 over t integration negative t by 2 to t by 2 absolute value of g of t square dt. The square root of Pg is known as the RMS value of g of t. Note, a signal cannot be an energy and a power signal at the same time. It has to be either power signal or energy signal. And here we have two graphs. A describes a signal with finite energy. The B describes the signal with finite power. That's it for this video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.